Hello there. Today we're going to be looking at the event system for the game engine. So an event system is a way for you to say, hey, I want to listen to this particular message, and we'll just say the message is Marco, right? And anytime the event system sends this message out, then anyone who's listening to it is going to perform the action that they said. So in this case, we'll say, okay, I'm listening for Marco, and when I hear it, I want to perform some function, right? And in this case, we'll just say that it prints Polo. Okay, so every time that the event system fires off Marco, then this function is going to run. So what that means is that we don't have to have a reference to this function directly at any point. If we want to print Polo, we can just send the event Marco into the event system. So the way that it's going to work here is we'll just do message underscore emit. It's the function name, and then we'll just put Marco. Okay, that's it. That's all we have to do. And that's going to run this actual function. It doesn't matter where this function is in the code. It doesn't matter whether this file knows anything about it. It's just going to work. One other thing is you can add multiple listeners. So if you say, I also want to listen to Marco, okay, but in my case, I want to run a function that exits the program. Something like that. Okay, now, assuming that, these are in the same order in the event system, then if you run message emit Marco at anywhere in your program, it's going to print Polo and then it's going to exit. However, if you change this to something else that doesn't exit the program, like, right, now, anytime you type message emit Marco, you're going to get Polo Stacy like this. There's no limit to the amount, well, there is a limit. It's the limit of the memory of the computer, but there's pretty much no limit to the amount of different functions that can be called when one event is fired off. So for instance, in our initialization system, we're going to call something like engine. Oh, I just realized that you can't see this. That says Stacy right there. Let's just draw over here. So we're going to call something like engine init. Okay, and then all of the different modules. Sorry, we should put this here just to make it clear. We're emitting this engine initialization event, and then all of the modules are going to be listening for this event when the engine starts up, and then they're going to run their initialization functions and do whatever it is they need to do to set up. So that's going to make it much easier for us, and we're not going to have to, like in our main function, we're not going to have stuff like, init underscore events init underscore whatever the renderer, etc. So that they're just going to take care of themselves. We're going to use this for other things as well. Okay, here we are. I've created a file in the source folder. I've made it another folder called message or MSG, and then a file called msg.h. Now, I've been calling it an event system, but in the code I actually refer to it as a message system. They're pretty much interchangeable in this circumstance. So, alright, so what do we need? We know that we need some kind of function to call when a message is sent. So we're actually going to use a type def for this. We're just going to make it a function that doesn't return any type and doesn't take any parameters. Okay, so we've typed out all of the declarations that we need. These are the three functions that we need externally anyway. Now we're going to open a new file, message.c. Alright, let's just copy these definitions into the other file. And let's start filling them out. What are we going to need here? Actually, before we fill these functions out, let's go over how we're going to store this data. We're going to store this in a hash table. And although I just did a video about dictionaries, I didn't want to use the one that I made in the engine because it has some inconsistencies that I didn't like that just made it a little bit more difficult to use in this scenario. So We're going to make our own custom hash table for this module. And the first thing that we want to do is define some limits for it. So I'm actually going to define these as macros. And it's going to be the table size, which is just the length of the array, or the size of the array. And then it's going to be the maximum length of a name. So the names that we're passing in, you can imagine that if you pass in a really, really long string, it's going to take up way more memory than it should. You might even be able to break things. So we'll set that to a value. In this case, 32 is probably good enough. The reason I'm defining these as macros rather than variables is because we can now use them to define arrays of sizes that we can choose at the top of the file rather than hard coding it in. So if we do something like int my array, then we can actually put in something like this, right? And it's going to make an array of this size, whereas usually you can't use variables. Now I have an idea about extending this later, where you can actually define the message table size and the message name maximum as sort of user-defined variables in the client side of the engine. So then here we're going to put something like if not defined message table size, then define it. So it should take precedence in the client definition. That means you can override these values if you need these to be larger, smaller, or just different in some way. First of all, we're going to have some kind of struct because we want to be able to keep the name and the things related to that name, which is the type of event, together. Alright, so the first two might be pretty obvious. It's just the name and then a list of the listeners. And the listeners are the functions that are going to be called when an event is fired off. But the last thing might not be obvious at a glance. It's a pointer to another one of these structs. And the reason that we're sticking this here is because if we have a naming collision, that is, the hash table is too small, and then one function name is computed as the same value as another function name, then they're going to try to go into the same slot in the hash table, which is going to be a problem. And we're going to deal with that using the chaining method, individual chaining, which is basically creating a linked list off of this hash table. If you don't know what I'm talking about, you can check out the dictionary video and I explain that in a bit more detail. Also, this list struct is another data structure that I've made in the past little while, and I'm going to be releasing a video about it probably next week. So I'm not going to explain all of it here, but it's basically just an array where you can add things and delete things from any point inside the array, and you can query it, and you don't have to worry about the memory and all that kind of stuff. It handles it for you. So that's what that is. So we're going to be using that to store the list of the functions that we want to call when an event fires off. Okay, here's what I was talking about before, how we can use the macros to define it's kind of variable, but not really variable. So we've got this table. This is where all of the events are going to be stored. The events and their listeners. At the moment we've set this to size 10. I'm actually going to set it to size 1 because I want to show that the linked list part works correctly. Okay, so since we're making a hash table, we know that we are going to need a hashing function. So let's go through that now. It's going to be very simple and very similar, or maybe even the same as the one that I did for my dictionary. So we know we want to return an unsigned integer. And we'll just call this hash. We're making it static because no one outside of this module needs to use this function. we want to get the length of the name that we've passed in. So we're using the strnlen function, which is going to give us the length up to a maximum value of this, the message name max. Val is just going to be the return value. So this is an integer representation of the string that we're going to put in. We want to make sure this is pretty much unique as much as we possibly can without being too crazy about it. So what we're going to do is we're just going to use this simple hashing function here. So it goes through each letter, it gets the number representation, the integer representation of that letter, times it by 23, which is a prime number, and then also times it by the position in the word that it is. So it's pretty unlikely that two values are going to be the same. But then we also use the modulo operator to make sure that the number that we end up with is within from 0 to max length of the table, which in our case is 1, so it's always going to be 0 for now. But when we make the table size a bit larger, then the numbers are going to be totally different. Alright, so we know that we're going to want to look up in this table and find out if we have a message in there. If we've already created the message type and put it in the table, or maybe it exists in one of the linked lists, we need to be able to find that out easily. So let's create a function to do that. It's going to be static again because no one outside of this module needs to know about it. Okay. So first we want to get the hash, which is this part here, or rather get the index. So the hash itself, we never get access to, but we get access to the index of the element in the hash table. So we'll grab that. Then we want to create a temporary pointer here that we can iterate through if we need to. So this is going to start at the beginning of the linked list, which is the hash table element. And then it's going to compare the names, and if they match, then it's going to give us that. But if it doesn't match, it's going to go to the next element in the linked list, and so on and so forth until it finds a match or it doesn't. Okay, now the next thing we want to do is we want to be able to subscribe to events. That is, tell the event system, hey, whenever you hear this string, then I want you to call this function. That's what this is for. So what this is actually doing is just adding a function pointer to a list. That's it. Okay. This first section here is for if we've checked the hash table and there's nothing there. We want to make sure that, or rather, we've checked the hash table for this particular type of message and we can't find it. Okay, that's what this is. Get message type. So this is null. But then we also want to make sure that in this slot in the hash table, there's nothing else. Because it could be possible that this is a naming collision. And if it is, then we don't want to just overwrite that entry. Because that means if you have, let's say, the message A and the message B, and they both take slot 0, then whichever one you register after is going to keep overriding the data from the previous one, and that's no good. So this is just going to make sure that there's nothing in here. Now, in the next section, we're going to deal with collisions, so let's do that now. As you can see here, the code is pretty similar, but we're going to have to make a new message type object and then stick that at the end of the linked list. So that's what we're doing here. We're just getting the last element in the list, which is what this is doing. And then we're allocating, or we're setting t to a new struct message type. Then we're just doing the same thing as before. We're setting the listeners to this new list that we've made, and we're copying the name into the new place. And then we're also setting the next pointer on the last element to this new element, just so that we can find it later. Otherwise it'll be, well, we won't be able to find it. Cool. So this should get subscribing working. Now let's move on to emitting, because we don't need to unsubscribe yet to test this. So we're going to move on to emitting first. Now emitting is pretty simple. All we have to do is look through the hash table, find if the message that we heard exists, and then if it exists, loop through the list and call the functions. That's it. Okay, we're done with the emitting function. Now, I've actually put a log error in here, tried to emit non-existing message type. So if you remember from our logging episode, this is just going to exit the program. And the reason is that I imagine if you are sending some kind of emit message, you want something to happen. So maybe you've made a typo, and this will just close the program and tell you. If you're just sending messages but there's no listeners, it doesn't really make sense to do that I can see. So, you know, I'll put this in here for now. Perhaps it's too strict and later we'll need to remove it, but for now I think it will be fine. Okay, let's test this. We should be able to well, let's have a look at the main file first. Okay, so here we are in the main function. We're just going to test this message module for now. So what I'm going to do is write up two functions here. One of them is going to be Marco, and one of them is going to be, I don't know, ping pong, I guess. I think that's a pretty standard test. So pong. And then all this does is prints to the console pong. Right, and now we're just gonna do exactly the same thing, but instead of Pong, it's gonna be Polo. Now we want to subscribe to ping, and when that message is sent, we want to say Pong. Now let's try emitting the message. And just do make and well, we have a lot of errors here. And I think I forgot to include the header file. Yep. Got a few errors. Okay. Argument type is int. Well, this is right, because I didn't include the string header file either, or stdio. I mean stdlib. Don't forget to include the header files, although I really wish it would just do it for me. I just haven't set up this editor yet to do that. It's the same problem. We didn't include log here, so we'll copy this, change this from list to log. Alright, finally. However, for some reason, the functions are not doing anything. Okay, there's one vital thing that I forgot to do in this message sub function, and that's actually add this to the list. So let's do that. There's a function called list add, which is in the list file, and we just want to add to the list, which is listeners, the callback. So we'll do that like this. Now this should be working. There we go. So let's go back to main. We subscribe to ping. We set the function pong. So let's try multiplying this a few times. So we subscribe 4 times. That means when this message is emitted, we should see pong 4 times. There we go. Very cool. Now we can do the same thing with Polo. So when we say Marco, we want Polo to be fired. Now we'll grab this, paste it here, say Marco, that says Carco. There we go, pong 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 Polo, that's what we were expecting. Well, pong 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 Polo. Cool. So as you can see, we don't have to know where these functions are after they're set. So this is a really simple example, but let's just say we're in some other module somewhere else. There's some other function running, right? And we'll just pretend that this is in a different place. Okay, when this function runs, it does something and then it emits a message, and the message could be ping, for instance. It does stuff here. Now we run this, and at the end it should say pong again. Well, 3 times, and it does. So you can see the subscription and the emitting can be in different places. This function has no idea about the main function or any of the subscriptions. It just emits a message. So that's pretty cool. Now, the last thing that we want to do is make sure we can unsubscribe. So let's write out that function. Okay, that's really as simple as it is. And the reason it's so simple is because of this list library that we've made. So make sure you check out the video on that if you want to know the details behind that. It'll be out on Wednesday. So what we do is we just check to see if we can get the message type, and if the message type is null, then we log this error and exit the program. We tried to unsubscribe from a non-existing message type. Then we just use the list rm function, pass in the list and the thing that we want to remove, and it will remove that instance. Or remove the first instance that it finds, I should say. So there is actually another function called rm_all, which will remove every instance that it finds, but we're not going to be using that right now. So that's it. Let's go back to the main function and see if we can test this out. So we've got 3 subs to ping. Let's try unsubscribing twice from ping. And we want to set this to pong. So that's 1, 2. Now we're going to emit. Well, now we'll just run this function again. There we go. So as you can see, we've removed 2 subs, and now instead of pong pong pong, when this some function emits its ping message, we've just got pong once. Now if we remove it a 3rd time, it should give us an error. No, it does not give us an error. Okay, so if nothing has overridden the spot of ping before you run another emit, then it will recognize that the spot for ping still exists, but there's no listeners there. So it won't actually error. I'm not sure whether that is good or bad behavior. I'll have to have a think about that. But for now, I think that's totally fine. Alright, thank you for tuning in for this episode of the Engine series. I hope you found it informative. Make sure to subscribe if you want to see more like it. There's going to be a next episode on Sunday. Every Sunday there's an Engine episode. And on Wednesday we're going to be explaining that list library that I was just showing you. So make sure to stick around for that. I'll see you in the next one. Catch you.